Welcome back, folks. In today's class, I will be talking about De Morbius theorem. And basically, if you can recall a little bit of exponentials, we're going to use those same functions, whatever we learned in the exponential. So if it is, for example, if it is 5 raised to the power 3, the final answer for this one will be 125. And if it is x raised to the power n times m, this answer will be x raised to the power m times n. So this is what we're going to use in this one. So if you have a complex number in which there is an exponent given to you, so for example 2 plus 3j raised to the power 3. Now I wanted to simplify this question. How I'm going to simplify with an exponent? So you convert it into the De Morbius theorem, so which is r e raised to the power j theta equal to r raised to the power n e raised to the power j theta times n. Now, how are you going to convert it into the exponential form? That's what the first challenge is. So the answer to that one is you will first of all find out the r value, which will be equal to square root of 2 square plus 3 square. And the coefficient of the rectangular coordinates means x coordinate and the y coordinate. So that is 2 and 3 in this case. And then the final answer for this one will be 3.61 r value. Now we figured out the r value. Now we wanted to find the angle. To find out the angle, we will use the tangent theta. Tangent theta equal to y upon x. Y value will always be the imaginary number value, imaginary number coefficient, shall I say. So that will be equal to 3 divided by 2. Tangent theta, theta value will be equal to tangent inverse 3 divided by 2, which is equal to theta. And the final answer for this one will come out to be 56.3 degrees. All right, so we have everything with us now. So our value was 3.61, 3.61 e raised to the power iota. Theta value is 56.3, 56.3, and then outside it will be n value, which in this case was 3. So 3 outside here. So 3.61 raised to the power 3 e raised to the power iota 56.3 times 3. That's going to give you the answer for this calculation. So this will be 47 e raised to the power iota, and then this will be 168.9. Now, I wanted to write it back into the rectangular coordinate from by, because this is from where I started from. So what I'm going to do is I'll write it in the rectangular, but before that I have to write it in the polar coordinate form. So I will write it as 47 times cos of 168.9 degrees plus j sine of 168.9 degrees. And then 47 times this value, which is 46, plus if I multiply 47 with this value, that's going to be 9j, and this will be a negative number. So negative 46 plus 9j will be your final answer. All right, so I'll highly recommend you guys to do question number 33, 34, 35, and 36 from the exercise 12.6. Now I'm going to take a question number 33 now. So question 33 is 3 plus 4j raised to the power 4. How I'm going to simplify this question? So again, I will write it in the exponential form. So for that, I will find the r value. 3 square plus 4 square, 4 square and square root, that will be 5. R value is 5, and angle tangent theta, which is equal to y upon x. Theta value will be tangent inverse 4 upon 3, and then tangent inverse 4 upon 3, which is second function tangent inverse 4 divided by 3, 53.1. Theta value is 53.1, and I will write it as 5 e raised to the power iota. Theta value is 53.1 and raised to the power 4 outside. So 5 raised to the power 4 e raised to the power iota 53.4 times 4. So this angle times 4, which is equal to 212. So, 212, 5 to the power of 4 is 625. Let me do the math also. 125 times 5, which is 625, e to the power of 212 point, I forgot the exact number. Let me do the calculation. 53.4 times 4, which is 200 and, well, 213 I got approximately. 53.4 if I'm writing. Yeah. So just let me do the calculation one more time. Second function, tan inverse of 1.33, 4 divided by 3, which is this number, multiply by, actually this is not 4, this is 1. Yeah, 1 times 4. So this number by multiply by 4, 212.5. And now I'm going to write it back into the rectangular coordinates, because that's where we started from. To get back into the rectangular coordinate, I have to write it into the polar coordinate first of all. 625, and e raised to the power, this number is cos of 212.5 plus sine of j sine of 212.5. And now you multiply this with this with this, that's going to give you the final answer. So 625 times cos of 212.5, which is minus 527.11, and plus the other value is sine of 212.5. Let me just quickly check my calculator if it is in degree mode or not. Sine of 30 is 0.5. Yes, it is in degree mode. So 212.5, and now multiply by 625, which is sine of this times this number, negative 335 oops 0.8 j. You can write j here also. So negative outside 527.11 plus 335.8 j. That should be your final answer. So hopefully you were able to understand what we did in these questions. And yeah, I will see you with another video. Till then, goodbye. I just wanted to check the answers before I let you guys go, so that I am also confident that we are doing it right. So I'm going to quickly check the answer from chapter number 20.6. It is chapter 20.6. It is, let me see, 12.6, sorry, not 20. Chapter 12.6. So chapter 12.6, the final answer for the given question is question 33. Yes, this is absolutely correct answer. So I'll see you with another video where we will talk about another chapter. Till then, goodbye.